Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. I want us to look at a type or a graph type of question, okay? Yes. So it is also vertical projectile motion. It says now a ball is thrown vertically upwards from the building, from the top of the building, and bounces a few times as it hits the ground. The velocity time graph below describes the motion of the ball from the time it is thrown up to a certain time t. Take downwards as positive direction and the ground as zero reference. The graph is not drawn to scale and all of that. So it is thrown vertically downwards like this, top of a building. It's thrown downwards, okay? Here's the ball, thrown downwards. Then it bounces a few times. They did not say. It bounces, let me see. The velocity will few times, okay? We need to know how many few times. It will be 1 and 2 because it reached the maximum height. Here, okay, it went down, it reached the maximum height for the first time, then it reached again. So now here, what is happening? If you are taking down as positive, it means now the velocity, remember the velocity increases as you go down, right? And we chose downwards as positive and it is going down. So it increases from here. So this is the initial velocity that was thrown downwards with. This is the initial velocity. Then it reaches the ground with the velocity. This is the ground. Okay. This is the ground for the first time. Okay, here, the ground for the first time. Then it does what? It bounces. Now, can you see it bounces inelastically? So it means there is a contact time. Okay, there is a contact time between the surface as well as the what? As the ball. Therefore, after that, after contact time, it went where? It went up. So can you see it went up with a negative velocity? Okay, with a negative velocity. Then it did what? It went to the maximum height. So it is here, it is going up, and when it goes up, it will go, the velocity will be negative. Why? Because you chose downwards as positive. Then it reaches maximum velocity here, okay? Then it goes to the ground. So whatever the velocity that it went up with here, it should be the same velocity it goes down with here. The velocity here and here will be the same because it returns to the same position. So we can see how it is. The velocity it is 27. So it means now the velocity at x, it is negative 27. What you go up with is what you go down with, okay? Then this it reaches the maximum height for the first time. Max height for the first time. Then this is max height for the second time, okay? And remember, what does the gradient of this? The gradient of a velocity time graph represents acceleration. What do I mean? M is equal to change in v divided by change in time, which is what? Acceleration, but which is the same as g, okay? Yes. All right. Now, this is also contact time, okay? This is the maximum height and all of that, okay? So here it reaches the ground for the second time, okay? It leaves the ground, here it leaves the ground, then it reaches the ground, then it reaches the ground again, then here it leaves the ground for the second time, okay? So here it leaves the ground for the first time, it leaves the ground, it goes to the maximum height here, then it returns to the ground, okay? Then it leaves the ground again with the same velocity thereof, okay? The velocity here will be different because now it hits the ground, the energy is lost, then it will increase again like that, okay, sharp. Now let us be in a position of answering the questions. Write down the speed with which the ball with which the ball is thrown downwards. Okay, this is the initial velocity, 10 meters per second. Okay, the initial velocity is the time velocity starts with, it is 10 meters per second, like that. All parts of the graph have the same gradient. Give a reason. Because now 6.2. Remember, why is the gradient the same? All parts of the graph have the same gradient. The same gradient, it is this one. The gradient is the same. Why? Because the gradient of the graph is gravitational acceleration. Or you can say m it is equal to g, and it is constant throughout. It is constant for free fall, actually, for free fall. Very, very nice answer there off. 6.3, calculate the height from which the ball is thrown. The height from which the ball is thrown, it is thrown initially here with 10 meters per second. Then it reaches the ground with 29.6 meters per second. Then acceleration is going to be positive because we chose down as positive. We want height. So I'm going to use this formula that says 6.3. Is it 6.3? Yes. Vf squared is equal to Vi squared plus 2a change in time. Sorry, 2a change in y. I choose that not as positive again. They also told me, I also know time. I can also use time. Whichever formula you want to use, it's fine. But you should use time t. Okay, if you're going to use change in y is equal to Vi change in time plus half a change in time squared, you have to use time as 2. So my final velocity here, it is 2.96 man 29.6 squared, and it is going downwards. Okay, initial velocity it is 10 squared plus 2, acceleration it is 9.8. I want change in y. Okay, when you punch that on a calculator and you do your mathematical gymnastics, you should get something more or less like 9.6 squared. Look, 29.6 squared minus 10 squared divide by 2 into 9.8, like that. Then I get a change in y of 39.6 meters. What did they ask? Calculate the height from which the ball. Therefore, please conclude, therefore, height, it is equal to 89.6 meters. 6.4, calculate time t as shown in the calculate the time t shown on the graph. Time t, how can I calculate this? Use gradient formula, saying now my gradient here, it is equal to change in v divided by change in time. And I know my gradient, it is equal to acceleration, which is 9.8. What is my change in v? My change in v will be, let's say, v final here. V here, it is how much? Okay, let me say, use it here. V here, it is how much? It is 0. V at t, it is 0. I get it at the maximum height, minus v here, it is how much? Negative 25. So minus negative 25 minus t here, it is t, minus t here, it is 8, minus 8. We know that it is equal to 9.8. Okay, therefore do your mathematics. When you do mathematics, you get t minus 8, it is equal to cross multiply. Okay, let me return that back. 25 divided by 9.8. Then you take 8 to the other side, it becomes 25 divided by 9.8 plus 8. So the time that you get, it is 10.55. This is t. Or what you can do, you can say, let us find the time it took from here to the maximum height. Okay, the first option, it is to find t using gradient, or the second one, you can say, let me find t when it reaches the maximum height. Okay, because I know the velocity that it leaves the ground, which it is negative 25, and the final velocity, it is 0, and acceleration, it is that one. Let me find time. We're going to say Vf is equal to Vi plus a change in time. What is my Vf? Vf, it is 0. V initial, it is negative 25 plus acceleration 9.8, then time. Therefore, my change in time, I get how much? I get 25 divided by, okay, 25 divided by 9.8. I get something like 2.55, 2.55. But this time is not, it is the time from here to here, but time t, it is the whole part, okay? So it's going to be what? T is going to be 8 plus 2.55, which now gives you 10.55 seconds, like that. Write down 6.5, write down time, the time that the ball is in contact with the ground at the first bounce. Okay, write down the time that the ball is in contact with the ground at the first bounce. This is the first bounce, okay? At the first bounce occurs here. So now the contact time, the time in which the ball is at the ground, it is how much? 2.2 minus 2, which is how much? 0.2. So the answer here, it is 0.2. Why? Because I'm saying it is 2.2 minus 2. Time at which the ball reaches its maximum height after the first bounce. Time it reaches the maximum height after the first bounce. So here it is the bounce. After the first bounce, it reaches the maximum height for the first trial. That time it is how much? 4,955 seconds. Also seconds. Value x, it is negative 27. Why? Because if it reaches the ground with 27, it means it left the ground with also 27. Okay, but in opposite direction. Meters per second. Is the collision of the ball with the ground elastic or inelastic? It will be inelastic. Inelastic. Why? Energy is lost. Energy is lost in deforming the ball. Energy is lost in deforming the ball, or you can say the velocity of the ball decreased. Therefore, if it decreases, it shows that there was energy lost, or there was energy lost thereof. Okay, so yes, that is it from the what is this? Multiple, so vertical projectile motion question where we dealt with what? With a graphs thereof. So thank you very much. I hope you enjoyed.